Welcome everyone. My name is Brian Hutchison. I'm a professor at Victoria College, and today we're going to be talking about trig ratios. Trig ratios, the sine, cosine, and tangent. So let's just draw our favorite 3, 4, 5 right triangle. I'm going to call this angle A, angle B, angle C. So with angle A being the one we're going to focus on, when we say sine, cosine, and tangent, sine of what? Cosine of what? Tangent of what? Well, the sine, cosine, and tangent are basically like little operators, and they're operators on angles. So I need to know what the sine of A is. I need to know what the cosine of A is. And I need to know the tangent of A is. Now, I always like to spell out tangent. It's just one of my pet peeves, but we can also just say tan, right? That's what you're going to see on your calculator, and etc., etc. But sine, cosine, and tangent. So we use these things to give us a ratio. So I take the sine, the cosine, and the tangent of an angle, and what it outputs is just a ratio. So now everybody with me, okay? So, ka, toa. I've heard a lot of these things, right? Different ways to memorize this, but like SOHCAHTOA. I don't know, it just works well for me. It works well for most people out there. Right? SOHCAHTOA. Well, what does that mean? It means O is opposite. H is hypotenuse. And A means adjacent. So when I'm asking for the sine of angle A, sine of angle A, it is nothing but a ratio of the opposite side over the hypotenuse. Well, opposite of angle A is 4, and the hypotenuse is 5. It spit out a ratio. Cosine is adjacent over the hypotenuse. So the adjacent has to be my 3. 4 is opposite. 5 is hypotenuse. Well, 3 has to be my adjacent. So my hypotenuse is a 5. Now for tangent. Tan of A is TOA. Opposite over adjacent. Well, my opposite is a 4. My adjacent is a 3. And here's a neat fact. Some people like to say that tangent is nothing but sine over the cosine, right? So the tangent of some angle, right, is the sine of that angle over the cosine of that angle. So I'll switch to blue. So it's the sine of A divided by the cosine of A. Well, we've already know what sine of A is. It's 4 over 5. And the cosine of A is 3 over 5. Uh-oh, a fraction inside of a fraction. But these aren't scary. All this means is 4/5 divided by 3/5. And when we divide fractions, it really is nothing but multiplication of the reciprocal. The 5's cancel out, leaving 4 over 3, which is the same answer we got. But it's so much easier to do opposite over adjacent. To do opposite over adjacent. So, another one. So let's have a right triangle. Let's say this guy is 8, this guy is 15, and remember your hypotenuse will be your longest side. That guy's 17. So I have two primary angles I want to play with, and this time I'm not going to label them A, B, and C. All I'm going to call is say that this angle here is theta. And what I want you to do is find sine of theta, cosine of theta, and the tangent of theta. They're just ratios. They are just ratios. So the best thing about a video is you can pause it. You can try something. You can go back and do it 1,000 times if need be. Don't let these triangles mess with you. And do not let them mess with you. So sine of theta is SOH, S-O-H, which means the opposite over the hypotenuse. Well, the opposite of theta is 8, and my hypotenuse is 17. Cosine is my ca, it's my adjacent over the hypotenuse. So my adjacent is 15 over 17. And lastly, tangent is TOA. So tan of my angle theta will be my opposite over the hypotenuse, opposite over the adjacent. So the opposite is my 8, my adjacent is the 15.